Hey everybody, thank you for coming. Today the title of my talk is Stop Hitting Yourself. I was just talking to a gentleman in the back on my way in and he came here pretty much just for the title. So I promised a few people I'll at least hit myself at least once, just to make sure everybody got what they came for. So let's get started. I've got a pretty packed slide deck today. Okay, 2 quotes to start off with. Computers do what you say, software should do what you mean. I'm not going to explain it too much now, but keep this in mind as I continue on. Second one, software is easy to use, but hard to run. So this is me. My name is Michael Russell. I'm an Australian living in the Netherlands in Utrecht. I work at Elastic as a software engineer for the infrastructure team. I currently respond to Michael, Mick, Mickey, Mike, Mikey, Russell, Rusty, Crazybus, and I'm looking for new nicknames. Potentially a Chinese one would also be great to add to the list. So if anyone has anything, just find me after the conference or at the booth for the Elastic stuff. And I enjoy food, traveling, gaming, and also, I forgot that I left this in, but photoshopping myself into ridiculous situations like that. Okay, so the title of the talk, Stop Hitting Yourself. For anyone not familiar with the reference, this is from a TV show called The Simpsons. And in The Simpsons, the guy on the left here, his name is Nelson, who was a school bully. And the guy on the right is a bit of a nerd, so the kind of guy who writes software. And what he's doing is he's filming him and he's grabbed his arm and he's just saying, stop hitting yourself, stop hitting yourself, stop hitting yourself. And the sort of connection to this is how I feel that the experience is a lot with modern software, where you go to deploy something and you immediately get an error. Oh, you need to set this configuration setting. You fix that, you deploy something else, and then you run into the next problem. And this is a pattern that I've seen throughout the years of my career, which just keeps coming back, even with newer technology. So after writing this speech and reading it back, I realized it was pretty negative because I'm pretty much complaining about software the whole time and showing the negative side of things. But I just wanted to say that I really enjoy what I do. I really like Kubernetes. I didn't get paid to say that, and they didn't actually pay me at all. So you can believe what I say. Okay, so it's going to be a sort of storytelling format. I've got a few different stories working from the older age of technology right up until modern day with Kubernetes. So we're going to start where everyone was around 5 years ago, writing bash scripts. So one day a developer came up to me and he said, I need you to do a restore of our production database. I've been working at the company for a few months. I didn't know that we had a backup, so apparently we did, which was good to know. And when I asked him about it, all he could tell me was, there's a bash script and a cron job somewhere. So this was off to a good start. We at least had some form of backup method. The question then was, will it actually work? So to go back even further in time, this is what the script looked like 20 years ago, the original version. So at this point, it's not too bad. It's just a MySQL dump command. It's putting that into a backup directory, which is hopefully somewhere that's going to last. And this is not too bad. This was okay. But this is how the changelog looked when I opened it up. I removed a few of the changelogs, but over the years, lots of advancements have been made, lots of changes have been done, little optimizations and things. And this script had history. I thought, if this has been running for 20 years now, it must be a pretty good script, right? This has been doing the production backups for 20 years. I can trust this. So this is what the script looked like from memory. I just had to make it up a bit. And at first glance, this looks pretty good. Particularly the top line up here, the important do not remove warning, and set -e. So for anyone who hasn't done much bash scripting, set -e is really, really important. So this is the first example of stop hitting yourself, and luckily someone else had already run into it. So what set -e does is it says that if any of the lines fail, any of the commands, I want you to actually exit and say it failed. Otherwise, the only thing needed for a successful backup was this line. So before the guy added this 5 years ago, the script was always successful because the echo backup successful always worked. So let's keep going. So some of the other problems that were in this script, we're not going to go into detail because it's not a talk about bash scripting or MySQL backups, is there was no table locking. And they were doing the dump per table. So that was already a bit of a concern. It meant I would then need to do the restore in reverse order, which isn't too bad, definitely possible. And the other thing is that a cron job which sends an email when it fails is pretty much the lowest level of monitoring you can imagine. If you don't get an email every day, you're just basically assuming, hey, my backup must have worked. You don't know if it actually ran, if your email server is broken. You don't really know anything. So there's actually only a couple of things that I think email is actually useful for. So one of those things is a human sending a message to another human when they already know that human. So that's one of the things. And the other thing is saving any articles for yourself or cat photos that you want to send to your girlfriend later. That's pretty much the two things I find email useful for. Some things it's not so good for is any kind of monitoring alerts, computers, automated systems needing to contact humans, and finally alerting the fire brigade. That's from the IT crowd. It's a real scene. So if you haven't watched it, I highly recommend the show. So the surprising thing is that it was a backup script with a lot of history, been around for 20 years. I wrote a restore script and it actually worked. And I was pretty surprised. And the site was working. It was up. When I searched for a job, it was a job website. There actually seemed to be some stuff in the database. So I was pretty happy with that. And I was quite surprised. So we now had a backup that was restorable, which was a pretty good upgrade from earlier in the morning when I didn't even know we had backups. So that's when you actually start to look into it and find out, oh, actually, it may have restored, but is all the data there? So the interesting part here was that the search index that I was looking at was a search engine, so not the MySQL database itself. So that one was okay. But the actual database was more or less completely empty. And when we had a look, there was only 8 jobs online when there should have been around 25,000. So at this stage, I thought maybe it was just a bad backup. Maybe something happened this morning. Maybe yesterday's backup was actually fine, or the week before. Let's see what we have. And what I did is I had a look at the size of the backup for the previous, so this was a daily backup, I think, so for the previous week. And I saw this, which was pretty horrifying, because you've got to imagine this is a script that's been running for 20 years. And what you would expect to see is that the jobs table was append only. So every job from the whole history of the company was in there. So you would expect to see a 500 megabyte backup approximately, and then every day getting a tiny bit bigger. So as soon as you see no backups that are even remotely similar to each other, you pretty much can conclude, this was one table as well, you could conclude, okay, we don't have a single valid backup for our job site in probably 20 years since the first version. So that was a fun discovery. So now to show you what actually happened in this case is that 5 years ago, someone had found the set-e. And you can see in the changelog here in 2010, add set-e to make sure backup actually fails. It's quite a good feature request. And the interesting part is this next changelog. So someone else came along, and once the backups were actually failing, they were able to fix the reason it was failing, and this meant that all of a sudden there was a greater use of data for the backups. So suddenly the disks were filling up, so someone thought, we need to have a way to compress the backups to save some space. And the line that got added in, it's very hard to do a changelog and diffing in slides, but I'm doing my best. But the important part that came in was this part here, where they're piping the MySQL dump command into gzip. And what's interesting here is that, as we said before, the default for a bash script is that as long as the last line works, that's okay, and everything else can fail. So that's fixed by the set-e. And then the new feature here, which is needed, is set-o pipe fail. And what this command means is that any command on the line, so this one, the only important command in the whole script, if that fails, that's okay. As long as the pipe into gzip, which could be piping nothing, is successful, and that tends to be always successful, it will still consider it to be success. So what was happening is the moment someone added that compression into it, we were back into the situation where every single backup was successful again. So in total, looking at the dates, there was a good 12 days of valid backups, but we didn't have them anymore. But it could have been nice. So to get back to what I said earlier, software is easy to use, but hard to run. Data is easy to back up, but hard to restore. And then hard to restore and verify. Okay, let's talk about something a bit more modern. Hopefully we've improved from our old bash scripting days. So let's start with Docker. So everyone who's used Docker has probably done this at some stage, or probably multiple times to test that Docker is working. This is the Hello World tutorial for Docker. Docker run Hello World. And not only do you get a Hello World message, but you also get a nice bit of output about what actually happened to make all of that magic work. There's one, particularly number 2, is what's very interesting here. So the Docker daemon pulled the Hello World image from the Docker hub. That happens to be a haiku, and it's been verified by our own haiku bot called Pumbaku. You can ask me about that later. But what's interesting about this is that none of that sentence is actually true. Pretty much every part of it can be picked apart and shown to be something that's going to set people up to hurt themselves later on. So the first part is that the proper wording should be, the Docker daemon checked if the image hello world with the tag latest was already downloaded and available locally. If it already existed, it did nothing. The next part is that it doesn't actually check if it's the right hello world image from the Docker Hub. If you happen to have another image called hello world with the tag latest, it would also use that as well. So then another layer on top of this is that the latest tag doesn't even have to exist. Latest does not mean latest, it's just a name, it's just a word, it doesn't mean anything. And just because you have the latest tag locally doesn't even mean it exists in the registry. And for anyone who hasn't run into this before, the complication of this is that if today you run Docker run hello world, and then someone else runs it next week, and then you run it again, you might get completely different outputs and different versions of the same container. So here's an example of where that can go wrong. Luckily, we knew about the latest tag going into this, and we knew, let's not use the latest tag. I read a blog post, it's a bad idea. Let's not do that. So at the start, this is what our Docker file looked like. So from CentOS 6.6, so CentOS is our base image, and then there was a bunch of business logic that I haven't included, and in the end, adding in the source code for our application. And the reason that I'm showing this and the title of the slide is someone came to us and said, you haven't patched production in around 6 months, which happened to be the amount of time we've been running the application for. So pretty much translated to, you haven't ever patched production. So when we looked into it, we found out exactly what I was explaining before. It's only going to connect and pull in the latest tag if that tag doesn't exist locally. So the build server already had the 6.6 tag, so it will never ever update it again. So we looked this up. There was an open issue on Docker. It's now called Moby, of course. And they said you need to pull the image first. So that's a pretty easy fix. We updated our deployment build script to include Docker pull CentOS 6.6 first, and then we could build our application, and that should work just fine, right? No, not yet. So the next problem that we ran into is that a version tag is completely up to the owner of the image of how they want to implement this. So this is the current documentation for the CentOS image, and the short version is basically, if you use that 6.6 version, they're going to match that to the ISO release of CentOS. So back in the days when you used to download a CD and burn it, that's a unpatched version of CentOS, which they've done on purpose. And their recommendation is to run yum y update and yum clean all inside of your Docker file. So this was good news. We found out, okay, here's the reason why. It's clearly documented. We just need to add this in. So we added it in, and everybody celebrated. We actually did a deploy and confirmed, yep, it's updated now. This is perfect. So that's why we were very surprised when 1 month later, I'll hit myself again. Why are you hitting yourself? Why haven't you patched production? So we then learned about the Docker build cache. So for anyone who doesn't know yet, any of those commands that you add inside, like this one, the way Docker determines whether or not to run these is based on the actual command itself. So the first time you run this, it is actually going to do an update and update everything. If you then run it again directly after, it's going to go, well, you didn't change the update command, so there's no need for me to run that again, right? And to make it even worse, we actually checked it twice. But on those 2 example times, it hit different build servers, so each time we saw it updating. So we really thought we'd solved it. So once again, the solution here is to override yet another default. So this is that you now need to pull the image first to make sure you've gotten any changes that are in there, and then build the image with the node cache. And the sad part about this is that one of the main reasons we went for Docker was all of the caching technology that we got, that we could build our images very quickly and deploy them, and now we need to download every single thing on every application deploy again. While making these slides, when I went to the documentation for Docker to look at the Hello World example, I noticed something very interesting. If you look at the output of this command here, let's see if I can go back quickly. That's a long way back. Okay. Sorry to give everyone a seizure with that. But the interesting thing here is that the output is actually different from the current version. And when I first saw that, I was really hoping that it was because they hadn't pulled the latest tag again, but it turns out the docs are just out of date because you can see it pulling the image. But that would have been quite a nice finding. So let's get on to Kubernetes. That's what everyone came here for, not to talk about bash scripting. Is there a bash con? That would be pretty nice. I can talk at that. So I was hoping that Kubernetes had taken a big step and actually tried to fix some of this tagging behavior that Docker has had, which has caused, I'm going to guess, at least some people here also the same pain that I've run through a few times. But unfortunately, Kubernetes maintains to try to be compatible with the Docker way of doing things. So the image pool policy is also set to the default of Docker. But luckily, you do have a nice option, image pool policy always. So you can pull in the latest tag if there are, depending on your tagging strategy. So let's now look at a hello world example for Kubernetes. This is a very basic one that a lot of people should have done. So just starting an Nginx container, and then we're going to expose the deployment with a load balancer. What's really nice about Kubernetes is that when you run a command like that, you can actually take a look and see what has Kubernetes generated for me. And when you take a look at the YAML file, you look through this and you go, yeah, this looks good. It's figured out rolling updates. There's a setting for replicas that I can tweak so I can make it highly available. Image pool policy is always by default, even though it says it's not when you use the kubectl run command. And resources, I don't have any resources, so I guess that's empty. So that's sort of the default experience that people will get when deploying an application. They might take this and tweak it slightly to their needs, but that's sort of where this goes wrong again. Here's a few questions that Kubernetes did not ask you and did not fill out in the template. And as I'm saying these, just think how you would answer these yourself and don't just listen to my answer. So when you're deploying your application, is it okay if all of the containers are running on the same host? No, you'd rather spread them out, right? That's why you're using Kubernetes. Is it okay if all the containers go down during a rolling upgrade of Kubernetes itself? No, I don't want that either. I'll turn that off, please. Should these containers always run or just sometimes? No? Okay. Should I check if the container is healthy? Hopefully that's an easy one. You asked for 3 replicas. Do you really want that many, or do you just like that number a lot? How about 2? Is 2 okay? So let's get into those with a few practical examples. So firstly, the update strategy. Like I said before, at first glance, this looks pretty good. You see it's a rolling update, max surge is 1, max unavailable is 1. So you think to yourself, what will that actually do when I do an update? So this is what I would expect to happen. I would expect I deploy a new version, that new version will actually get deployed, and the moment the version is deployed, it's then going to remove the old one. That's the standard way of doing rolling updates. You don't want to take one down and have any downtime. But here's what actually happens. Once again, I'll hit myself just for the guy up the back there. You're welcome. And what actually happens is you're going to deploy the new version. At the same time that that new version is being deployed, Kubernetes is going to say, I'm allowed to have max surge of 1, so it's going to have 2 containers running at once, and max unavailable at 1. So as soon as the first one launches, it goes, I'm allowed to have 1 unavailable, I'm only supposed to have 1, let's kill the old one. So at the same time that it's being launched and starting, the other one gets removed. And what actually happens here is that if your new version has a Docker image that was missing or a tag that's gone, it's actually just going to take down your application, which is pretty unexpected, I would assume. And for an Nginx example, people are thinking you should probably have more than 1 replica, but there's definitely a lot of Kubernetes use cases where you are just doing a single replica, where deploying a new version should not cause your application to go down for a controlled change. So what you actually want, of course, is to set max unavailable to 0. And there's actually a couple of reasons for that. And the other reason is that if you were to set things to 3 replicas, if you remember before, one of the questions was, do you really want 3 or do you just like that number? And that's the example that this also fixes, is that once you say max unavailable is 0, it's going to always keep 3 during a rolling upgrade. With max unavailable of 1, what's going to happen is it's going to start a new one and at the same time remove 1. So during an upgrade, you're going to go from 3 replicas down to 2. So you're just willingly giving up a third of your capacity during an update. And then, you're still open to node failures and everything else. So that's where that do you really want 3 or do you like the number comes from. So here's the next thing. By this stage, you're probably thinking, I fixed the rolling update strategy. I've got an application that just can't be taken down. It's pretty much invincible at this stage. So let's see what happens if there is a Kubernetes upgrade. So quite often, this is not being done by the users of the application, which makes this even more surprising. But imagine we've got our Nginx deployment running, we've got 3 replicas, we've got everything configured properly, we've tested it all nicely, and all of a sudden our application goes down. And we log into our Kubernetes cluster and we have a look and we see 3 containers not running. And you think, okay, that's not ideal. And the default, if you remember the question before, is it okay if all the containers stop working? That's exactly what happens out of the box. If you do a rolling restart of each node and the container fails to start up again somewhere else, it's actually going to just keep going. But luckily, there is a solution, but you do need to configure it. So that's where pod disruption budgets come in. With a pod disruption budget, you're actually able to tell Kubernetes from a user point of view, this application can only have one container unavailable at any one time. So what's going to happen in this case is Kubernetes is going to try and upgrade a node. It's going to drain it, move the container somewhere else. If the container fails to start up, Kubernetes is going to stop the whole cluster upgrade just for you because you're special. And it's going to annoy everyone else until you fix it. But you've at least prevented some outages for something that you may not control. Next example, if a Kubernetes node crashes, everyone here is probably using some form of cloud in some way, probably AWS or GCP, and have at some stage in their lives had a virtual machine actually crash or die or disk fill up or something else happen to it. And what's interesting about this is that by default, if you deploy something on Kubernetes, there is no guarantees about where those containers will run. If you're running a 3-node Kubernetes cluster, it's very possible that all of those containers will end up on a single Kubernetes node, a single virtual machine. And if that machine does actually crash and is unable to connect to Kubernetes, the default waiting time is 5 minutes. After 5 minutes, Kubernetes will go, I think the node's not coming back now, let's start those containers somewhere else. So 5 minutes of downtime just because you haven't set up your pod anti-affinity. A lot of these are very hard to say. So the way pod anti-affinity works is that this is a way to define where your containers can and can't run. There's also affinity and anti-affinity. And in this example here, the only really important line is this one here, the topology key. And with this, you're able to say, for this Nginx deployment, I want to make sure that all of them are running on a different host. So this is going to guarantee that they don't end up on the same node. It's then also possible to divide this up by zone or on any other labels that you might have on your nodes. But just by adding this in, you can simply now say, make sure the container is separated and running on different hosts so that I can actually survive a failure. Feels like something that should be a default, but it's just not. So at this stage, things are pretty battle-hardened, and you'll think there is no way something could take this down that we could fix by adding in some configuration. And you'd be pretty much right. We're nearly there. And because you're doing so well, some other people in your company say, hey, that Kubernetes thing actually seems to work, and you guys are now getting work done. Can we have some of that Kubernetes? And of course, you want them to use it as well. So you help them out, you show them how it works. But they've come into it later than you, and they've seen updated documentation, and they've also seen this resources thing. So they thought, let's configure resources because someone actually read the docs and understands what it does. So at this stage, they've deployed a few applications, they've asked for some CPU and memory requests, and now your application has gone down. And you can't figure out why until you actually have a look at what the resources do. So out of the box in Kubernetes, if you use no resource definitions, it's considered to be best effort. So in a world where all resources in Kubernetes are best effort, it actually turns out pretty okay. Because if you have 2 containers running on a host and they both want to use all the CPU, they'll get half each. If you add a third one in, they're now going to get a third each. And this works great. But then what happens is someone comes along and does things properly and actually says, hey, I want some CPU. Kubernetes is going to go, oh, that's okay. No one else wanted any. I'm just going to give all of that to you instead. And it's going to starve the containers of any resources, and at worst, actually just completely delete them because they're best effort. You didn't tell me they were important. You said you wanted me to run them, but you didn't really say they were that important. So this is what the resources stuff looks like. Hopefully everyone's seen it before. The quick explanation of how it works, because a lot of people get confused between limits and CPUs, is limits and requests, sorry. So limits is what it sounds like. That's a hard limit. So if you set the CPU limit to 1000 milli-CPUs, which is 1 CPU, it's going to just limit your process to that speed. The memory limit at 500 megabytes, when you hit that, it's going to do an out-of-memory kill, a bit like Linux does, and actually restart the container. The request is actually going to reserve these amounts. So if you don't add any requests in, you're going to run into the same problem before. It's kind of like best effort with a limit. It's almost worse than not having anything at all. But a request is going to guarantee that at any time, your container is going to be on a node that has at least 1 CPU and 500 megabytes of memory for you. And then, of course, you're going to want to set these as well. So if everyone starts setting how much memory they want, everyone's just going to say, I want 20 CPUs and all the memory. So what you can also set up is you've got resource quotas, where on a namespace level, you can say this team or this namespace has access to 50 gigabytes of memory and 20 CPUs. And then you're going to find out it's very painful to keep telling every single developer, every single pull request, don't forget to add in resources. So you also have default resource limits where you can define a default setting for anyone who doesn't set it. So if you deploy an application, don't set any resource limits, you're going to get a certain amount by default, which is probably not going to be enough, but enough for them to realize that they need to actually do it. So it's a good way to hit them back, I guess, is a better way of putting it. So I think this is the final one. And all of these are based on a true story of constantly trying to get an application working, running into problem after problem. So in this case, your website is functioning, but someone has a look at the logs and you're losing about 1 in 10 requests. And you have no idea which one it is or what's going on. And after taking a good look, you do find out that one container has got itself into a bad state and probably shouldn't be receiving any traffic. So the nice answer to this is you have readiness probes and liveness probes. Both of these support doing HTTP calls, but also just running a shell command. And once again, it's another thing that people get very confused. I would urge everyone to at least go for a readiness probe. Readiness probe is used for a whole bunch of different use cases in Kubernetes. So when you're doing an upgrade, it waits for the readiness probe to be going. When you have a service with a load balancer, the readiness probe defines whether or not it's actually inside of the service. When you're doing Kubernetes upgrade, the pod disruption budget uses this readiness probe to decide, yes, this container is actually healthy again. The liveness probe functions the same way, but this one is only used to restart the container if it's failing. So this should be something normally a bit simpler where if the HTTP server is not responding at all, let's try restarting it and see if that helps. So here's the thing that you guys should take a photo of to summarize all this if you don't want to remember it. But this is just all of the things that I've gone through that if you're not setting these for production already, you really should be. So just once again, resource request limits and quotas to make sure that you've actually got some resources for your containers. Liveness and readiness probes to make sure that when they are failing, that it doesn't take down your whole application and that requests aren't sent to a bad service. Pod disruption budgets to make sure that Kubernetes upgrades doesn't take down your application. Anti-affinity rules to make sure a node failure or a zone failure is not going to take down your application. Upgrade strategy to make sure that a normal deployment is not going to take down your application. And then the things which I haven't covered, which I won't have time for today, is to make sure that you have proper logging, monitoring, and alerting. Alerting, as we saw before with the email example with cron jobs, is way more important than actually having the monitoring in the first place. Actually being aware, being able to trace back, see what happened. And finally, once again, another true story, a way to restore your applications if someone accidentally deletes the Kubernetes cluster. Luckily, we keep all of our configuration under version control and our secrets are persisted outside of the cluster in HashiCorp Vault. So it is possible, but it's something you need to think about in case you ever have to do it. It can be quite difficult when you have services dependent on each other as well, how to restore stuff in the right order. So after writing this talk, how long have I got? Okay, so after writing this talk, I had to actually start questioning, why is software like this? Why do we do this to ourselves? Why do we make us hit ourselves? So part of the reason here is that it's really about those first impressions. If you wanted to use Kubernetes and you first had to listen to my talk before you could get an application running, I don't think there'd be many people at the conference here today. It raises a barrier of entry. People can't just play around and try it out. And there's also a lot of use cases for people where it's completely fine that if an application is down, that they can just talk to someone and someone can log in and fix it. And the final one, which is I think is the main reason for this, is purely backwards compatibility. When some of us were first using Kubernetes, none of these features existed yet. If you suddenly upgraded to a new Kubernetes version and it started spreading your pods around when they used to all run on one host, that could be pretty unexpected, and that would be breaking backwards compatibility. So here's a few ideas I have to try and improve stuff. One is actually talking about it, making sure that people are aware, and this doesn't apply to Kubernetes, this is about all software. Reading the documentation, actually testing it for yourself. How does failover happen? What happens if I do something silly like breaking the configuration? How does it respond? Maybe also creating some documentation for these. Here's an example of a battle-tested application using all of these features. Maybe it's even possible to start thinking about changing some of the defaults. Maybe some of these should become default settings, a bit like the rolling upgrade strategy. Another potential idea is to go even further and have a code level implementation of this, a way to actually say this namespace, this cluster is in production mode, and it's not possible to deploy it without these things being configured. And finally, it could also be something potentially added to a Helm chart template. So another quick final thing from me. Deploying to production is easy. Running tests locally is hard. This is a little plug for a tool that I've been working on lately, which focuses on the opposite end of this problem. So right now I say, thank you, that it's actually too easy to deploy something into production. Currently I'm working on Helm charts for Elasticsearch, and the biggest concern that we have is that people can now deploy quite a complex application with a single command. And that's going to lead to a lot of people making mistakes who don't know Elasticsearch, who don't know Kubernetes, who don't know how to run a cluster. And it's sort of setting them up for failure a bit where you're worried about this. So this tool is about approaching things from the opposite angle. That while I find it so easy to install a persistent, highly available cluster on Kubernetes and not understand it, I find that the opposite end of the spectrum, actually running tests in a development environment, is way too hard and difficult. A lot of my effort and time at my job goes into actually making sure that something that I write will work on Windows, Mac, Linux, in the CI environment, on Jenkins, on Travis CI, and everywhere else. So the way that Lope works is if anyone's ever done the trick with a Docker run command, where you mount the current directory inside of the container and put on --rm and ti and run a command, this is kind of that, but on steroids. So it's also going to forward your SSH agent into the container, even for Windows and Mac OS, so that you can run Ansible from Windows, Mac, or Linux, or in your CI environment using the exact same versions, the exact same system libraries. It's also going to forward environment variables, attach the Docker socket. It also supports proxying any commands to the host for any specific tooling like Keybase, where we have like a use case where we need to decrypt something from Keybase to unseal Vault. So it's got the idea is that there should be a single way for everyone to run a command and have it just work, but also for CI. And that was it. Thank you everyone so much for coming. Do we have any questions? Yes. So the question was, can you go back to the summarize slide? I'll leave that one up. The slides are also online.
Yeah. Okay, I have a couple of questions. The first point, result request and result limits. So what's your recommendation on this point? So we always need to set a result request the same as result limits, or we should set it as the best effort or something. And the second question is the last point, a way to restore your application if Kubernetes get deleted. Version control deployment. So how do you do it right now in Elastic? You use Helm, or you just use plain Kubernetes object and keep it in Git version control? And the second part is secret persistence. How do you achieve the secret persistence?
Okay, so the first question was, with resource requests and limits, what do you recommend for doing that? For most of our applications, we tend to set the request and the limit to the same amount, because there's nothing more frustrating than finding an application that's performing worst, and that's because it's no longer able to burst anymore. It's a cool feature to have, and it sounds great, but once you get used to it and have a quiet cluster, you don't want someone else deploying a new application to take away performance from the first one. So I would really recommend, depending on your use case, like if it's something that's user-facing that needs to serve a request in real time, to really consider setting those the same. If you're running like batch processing, where you really do want to use every last CPU and you're not worried about being slower and faster during periods, then yeah, not setting limits could make sense. And the second question was how we do actually managing our configuration at Elastic. So right now we use Helm charts, and we then use the Terraform Helm provider to manage the Helm charts. And the main reason for that is that we can guarantee the state of that. So you don't need to make sure that everyone is running Helm upgrade and that they have the latest version deployed. There's nothing worse than going to deploy something and then finding out the current version is a couple of versions older than what's currently in Git. And the other advantage that you get using Terraform for that is that you can also define dependencies. So like I said before, when we had to restore our cluster from nothing, we weren't using Terraform at the time. So we had to figure out what was the correct order to install stuff. So like, okay, Elasticsearch needs to be installed because Metric Beat talks to Elasticsearch, and then Vault needs to be installed first because that's where the secrets come from. So it also allows you in code to define all of the relationships you have. So for secret persistence, we're storing that inside of HashiCorp Vault, which runs in Kubernetes, which is a nice chicken and egg problem. And there's a really great tool called the Kube Vault Controller. And what this one does is it lets you, in a Kubernetes native way, synchronize secrets from Vault to Kubernetes without needing to have your application be Kubernetes aware. So it will just create them as secrets, which you can use as environment variables or in config maps. Answers your question? Okay, thank you. Anyone else? Oh, there's one over there.
So I have a question that, so how can we make the consistency for the test environment and the production environment? So because I think it's a big headache for things online, because always when we have a production environment and the staging environment, and something of the staging environment is also not exactly the same as the production environment. How we build a consistency between these two environments.
Yeah, so you're talking about having two separate Kubernetes clusters for staging and production.
Yeah.
So I don't work for HashiCorp, but I've been plugging their products. But we also use Terraform for this. And the reason of having a staging Kubernetes cluster and a production one allows us to test Kubernetes changes on the staging environment. And if you're not familiar with Terraform, you define the state that you want. So you have much better guarantees that it's actually the same environment as you have in production. But that's always a difficult problem. But at least with Kubernetes, it's made it a lot easier to get something that's very, very close. 1 minute left. Okay, I think we're good. Thanks, everyone.